Hello, everyone. So here we are on the KoolBeens Cafe. I want to change the name of this channel and separate the cool and beans in two words instead of one. Okay, so let's see what's going on. I have a topic that I want to discuss today, and that topic is the latest on long COVID, especially neurological symptoms that include central nervous system symptoms and the peripheral nerve symptoms, and what could be going on and possible solutions. That's what I want to discuss. But let's see, how is everyone? So Cynthia is here, Alexander, um, Faraz, Paul, so Jean, BR, BR. Thank you very much. So I think if it is useful, we'll keep these chats here and we'll go from there. Okay. So uh, Gina used to travel. Am I pronouncing your name correctly? Gina used to travel. Margaret is here as well. Welcome. So the topic I want to discuss today is so of course it's a chit chat, but I want to present this topic of neurological symptoms and long COVID, both the central nervous system issues with anxiety, depression, memory loss, etc., and then the peripheral nerve issues with the burning sensations, paresthesias, pain, tingling sensation, vibration sensation in the body. So, so let's start. So thank you very much for joining me. There are 12 people right now, so that is more than I expected on this channel. So let me bring in. So ready for this study? It's kind of a long study, but I'm going to show just some parts of it. So this is the study. Let me remember that we are at page number 9, and I'm going to go to the top. The study says a causal link between autoantibodies and neurological symptoms in long COVID. The preprint link is here. Let me put that in the comments. So let me first read the abstract and then some things. So summary is that SARS-CoV-2 infection triggers the generation of diverse and functional autoantibodies, so self-attack, even after mild cases. Persistently elevated autoantibodies have been found in some individuals with long COVID using a greater than 21,000 human protein array. We excuse me, we identified diverse autoantibodies targets in long COVID patients that correlated with their symptoms. So the first thing that they observed was that in various patients, there were various kind of autoantibodies giving rise to various kind of tissue attack and of course varied symptoms. Purified immunoglobulin G. So very quickly for the immunoglobulins, we know about them already, but still this is a B cell, and when a B cell, it's a lymphocyte, when a B cell is activated, so when B cell is born, we know that it always has a binding region that is of a specific type. This is too difficult a region I made, so let me make it a little easy to redraw. So let's say this is its binding region. We have done this discussion a lot during COVID, right? So this B cell is making this. When the B cell is born, it always continues to make IgD, which is present on its surface. Then as this B cell makes its daughters and as it becomes active, so let's say the antigen is presented to this B cell, which can fit this pattern. So let's say this is the antigen. Then this B cell will become active. It will start proliferating. That means it would divide and increase in numbers. the daughter cells will be formed. The daughter cells will start producing IgM. That is the first protein set that is produced. Then these IgM producing cells and this original cell will further divide into next generations if the immune system is still continuing to be triggered. And the if you remember MDGA, so this is called class switching, right? So we switch from this class IgD to IgM. Once again, for those who are immunologists or immunology or medical professionals or students, D and M are always produced together. But after that, only one kind can be produced with the class switching. So the next kind is G. So IgG is produced. Then further class switching can cause IgE production. Further class switching can cause IgA production. So eventually there are going to be cells that are producing D, some cells that are producing M against the same pathogen, then some are producing IgG, some E and A. This IgG is what they're talking about. And what they're saying is that the IgE during long COVID ends up cross-reacting our body's tissue. So let's say that this was the antigen from the virus. So maybe this is something on the spike protein, maybe this is some part of the virus, whatever it is. Let's say this was that antigen. Now imagine we have a nerve. So let's say this is a neuron, happy neuron, and it has myelin sheath on it. It has an axon. So imagine some part of this myelin sheath or the nerve or the channels in the nerve, meaning some part of this nerve also has a pattern that is similar to the pattern that was on the virus or the spike protein. So now these two patterns look the same. Because of that, these IgGs can bind here as well. And that is how the self-attack will occur. And of course, the question is not just the binding of the immunoglobulin here. When the immunoglobulin G binds, it activates complement. So complement is another protein, set of proteins produced by the liver, which when activated, they will settle on the nearby tissue. So of course, remember these antibodies are microscopic. So when they are settled on a tissue, they are really on the tissue. So when they activate the complement is really touching the tissue as well. So this complement will become activated and form structures that are like little tiny pipes. These are called membrane attack complexes or MAC. When these complexes occur, they will attack, of course, the tissue nearby without knowing if it was a physiological tissue, meaning it is a body tissue or as a virus tissue. They would just settle on the tissue where they are activating, and they would create a hole in that tissue. So this is why they're called membrane attack complexes. So once they have created this hole in the tissue, now the things from outside can get into the tissue and the things from inside can get out of the tissue. So now the integrity of the barrier of the cell is gone, and this cell now will get damaged or destroyed. So this is how IgG destroys or damages tissue. Now, if it damages nerve tissues, then the neurological symptoms will appear. If it damages, let's say, vascular tissue, then the vascular, cardiovascular symptoms will appear, and so on. Faraz said, 80% spike protein sequence is human homologous. Is this a dubious or irrelevant point? No, it is a good point, because we know that spike protein can do this. that it can create antibodies that cross react. And we also know that there can be auto-idiotypical antibodies that can cross react as well wherever the spike protein works. I've done those discussions before. So it's a good point. So keeping this in mind, that there will be IgGs that are produced. Now let's look at this study. So they're saying, and sorry, one more clarification here. These IgGs are produced by the patient's body and now are targeting or attacking patient's own tissue. This is why these are called auto antibodies. They are auto, they are directed against self. So that is why they are auto, and they are antibodies, they're IgGs in this case. So purified immunoglobulin G samples from these individuals reacted with human pons tissue. So if we look at the brain, once again, I'll make a not so beautiful brain, but I'm trying. So this one, so let's say this is spinal cord that is in our spine, that passes through the spine. This is the brain, the cerebrum. Then here we have cerebellum. This is cerebellum. This part of the brainstem. So brainstem is from medulla. Let me make it blue here. So from medulla all the way to midbrain, this area is brainstem. So imagine where your neck is connecting with the skull. Right above that, in the skull, there is a stem-like structure that is connecting the spinal cord. Let's make spinal cord in red. To, let's make brain in green. So it is connecting the spinal cord to the brain. So here is another tissue, nervous system tissue. In this tissue, the lowest part is the cerebellum. Oh, sorry, it is medulla. Then this is pons, P-O-N-S. And then this is midbrain, this area, and then we have the brain itself. Now, when the spinal cord passes through the spine, it makes nerves, right? Those nerves will then go into, and I'm taking liberty at drawing it, these nerves would make smaller bundles, and these bundles of the nerves will go to various limbs and areas. For example, the nerve that passes in the back of our leg is sciatic nerve, correct? So these are called, when they come out, when the nerves come out of the spinal cord and the brain, they are called peripheral nerves, peripheral nervous system. They make up peripheral nervous system. There are some ganglions as well and other tissues too. And then spinal cord and the brain, this whole thing is called central nervous system. So if we go back here, antibody reactivity to sciatic nerve, that is the nerve that is in the back of our leg, and meninges. Meninges is the covering of the nervous system tissue. Meninges correlated with patient-reported headache and disorientation. Passive transfer of IgG from patient to mice led to increased sensitivity and pain, mirroring patient-reported symptoms. So when they took those antibodies from humans and washed them and then put them in mice, mice developed similar symptoms as humans did. Similarly, mice injected with IgG showed loss of balance and coordination, reflecting donor-reported dizziness. Our findings suggest that targeting autoantibodies could benefit some long COVID patients. So long COVID patients who may have issues with keeping their balance or coordinating their walk or the other body movements, or having tingling, burning, pain sensations, can actually benefit from this paper. And I'm going to show you, they have a few lines for how to manage this as well. So Cynthia says that they'll be sad to miss the chit chat. I understand. So the what I did was I asked my team to put a post on the other YouTube channel to say today we'll have a chit chat on this channel. So we'll keep doing this, and so hopefully people would uh, will find it. But thank you for pointing it out. Okay, so back here with this knowledge, let's read some parts of this. Why not I go to the solution first? So if I go down to the page number 9 here, and then some more in the discussion. Sorry that I've not colored it, so not highlighting it gives me hard time as well. But here, so they are saying for how do we help these patients. One is benefits from IVIG treatment was also reported in long COVID patients with small fiber neuropathy. So this neuropathy, small fiber neuropathy, I did not touch upon that. I'll do that in a second. But the peripheral nerves that are present near the skin, they are called small fiber nerves, or free nerve endings, or free nerves as well. So benefits from IVIG treatment was also reported in long COVID patients with small fiber neuropathy. However, IVIG does not help all patients, and currently there are no guidelines or clinical tests to distinguish between those who would benefit and those who do not, underscoring the urgent need to develop new biomarkers. So, what they're saying is that we actually do not know who should receive IVIG, and that means there should be some labs that should be run on a patient. And then, based on the lab results, we should say, yes, this patient is a candidate for IVIG or not. Then, demonstration of functional autoantibody may be used as a diagnostic tool to inform IVIG therapy. So, then they're saying that we can have some autoantibodies selected. And if we find them, then that would become a demonstration that we can give them IVIG. In addition to IVIG, autoantibody driven diseases may be treatable with mechanisms to degrade circulating antibodies. So imagine that imagine there is a cluster of B cells sitting somewhere in the bone marrow, in some lymph node, circulating in the blood, wherever they are. And they are just continuously producing antibodies. These antibodies are now circulating in the blood circulation. So hordes of these antibodies are running around, getting out of the circulation, attacking the tissues, causing all of these kind of issues. And now that I'm here, let me just quickly talk about small fiber as well. So imagine that this is skin, any part of our skin. We, right under the skin, when the nerves arrive here, these will become naked, meaning they would lose their myelin sheath on them. They will become naked, and they would divide into many branches, and there would be small receptors on it. If you watched my lectures on pain management, I discussed this as part of lateral spinothalamic tract in the very first lecture. So these are called free nerve endings, free nerve endings. And these nerves are the intraepidermal free nerves. Intraepidermal free nerves. I believe that is a name. These are the nerves. These are the nerves that they are talking about, or that we are talking about when we talk about small fiber neuropathy. When these nerves get damaged, we end up with small fiber neuropathy. So these are small fibers and they get inflamed. Now, when there is small fiber neuropathy, the patient will feel pain, vibration, paresthesias of other kind. For example, they'll feel temperature or cold. So temperature variations, pressure variations, vibrations, pains, tingling sensations, crawly sensations. These are the sensations that they would feel. Why? Because the free nerve endings function is to work with the pain, touch, pressure, temperature, vibrations, 2 point discrimination. So, because these nerves function is that way, if you irritate them, they would send signals to the higher centers that, hey, I am stimulated. They don't know that I'm damaged, and that is why I got abnormally stimulated, but they feel stimulated. No pun intended. They feel, and when that signal goes to the higher center obediently produces that sensation, the sensation that should be labeled for that line, for that nerve. So if this is a pain nerve and it is inflamed here and it got activated because of inflammation or irritation, when that nerve is activated, the brain would just think that there is pain in this area. Or if it is a vibration nerve, then the brain would feel there is vibration here. So that is why many patients of long COVID with the small fiber neuropathies, they report vibration sensation in their body, or they report various tingly, crawly sensations or pins and needles in their bodies. That is because the free nerves or small fibers are damaged. Sigrid says Dr. Bean is doing again. Long COVID, IVIG. So I wanted to pick up wherever the new studies have reached, which I have not touched for almost 6-7 months now. And I wanted to present those for those who are still suffering with long COVID. Mike Ma says, did they start at 6? It is a regular event. So today's first one after a long time on this channel, yes, it started at 6, and then hopefully we'll continue at 6 every week if there is interest. It's a new channel as well, and so there may not be much awareness of it. So we'll see how it goes. But plan is to do it 6 o'clock every Friday. Okay, so now we know the small fiber neuropathy. Now we know why it causes this tingly, vibrating, pressure kind of sensation, cold, hot, pins, needles. Now, if I go back here, in addition to IVIG, auto antibodies driven diseases may be treatable with mechanisms to degrade circulating antibodies. So now what we were discussing was that as these antibodies are being produced and they're circulating and they're running around and they are reaching various tissues and they're attacking them, so maybe we can just degrade them, we can destroy them. So that is one possibility. For example, FcRn inhibitors. So fraction constant inhibitors. So there are drugs. What they do is, if I make a antibody, big antibody over here, antibody has a variable portion where every antibody is different on this area because it binds to various kind of antigens. So this is why it is called variable. Someone would look like this, another one would look like this, another one would look like this, right? So they all have a variable area to bind with various kind of antigens. However, this part is constant, so we call it fraction constant of the antibody. From the fraction constant, the antibody can bind to the receptors on various immune system cells and activate them. So these are called, these receptors, imagine that this is a macrophage, or this is a T cell or B cell or some cell, immune cell that can receive an antibody, a mast cell, for example. This receptor is called Fc receptor, right? And we can become a little more sophisticated and we can say FcIg receptor. What does that mean? Or IgG receptor, right? Or Fc gamma globulin receptor. What that simply means is IgG, can bind here and not IgA or D or others. So this is a receptor for IgG. So now, once again, if I go back, they are saying we can destroy these antibodies by having drugs that would inhibit their fraction constant. So we could affect either these receptors here and kind of stop this activity, or we can affect these constant area or the receptor for it. Neutralize their action by giving various drugs that can prohibit their activity, or remove them temporarily by plasmapheresis. This is something that Dr. Razia Pretorius does a lot, but not for antibody cleaning. She does it for microclot cleaning, right? Or targeting for antibodies secreting cells, anti-CD20 monoclonal antibodies or CAR T may be considered. So the world has reached where 3 years ago I spoke about this with Dr. Bill Murphy. So what they're talking about is that these B cells may need to be attacked and killed or destroyed or disabled. So how do we do them? These B cells have CD19 and CD20 on them. CD19, they have many other markers too, but these are defining markers. So what are these 19 and 20s? Every cell on its surface have a bunch of proteins that are dangling, and there are some proteins that are unique to that cell category. For example, all B cells do have CD20 on them, cluster of designation 20. And so from this, we can recognize that this is a B cell. So maybe give drugs that would identify, or give antibodies that would identify a CD20 cell and attack that cell and kind of kill it. So maybe that is a solution. And then CAR T cells. So you take a T cell, a cytotoxic T cells, whose job is to kill other cells, cytotoxic, and then you teach it how to connect with a B cell that is producing these bad antibodies, and send it in to just kill these B cells that are producing bad antibodies or autoantibodies. The discussion I did with Dr. Bill Murphy was on the same lines, that we will have to bounce, I call it bouncing the bone marrow. We'll have to, just like we restart a computer, we'll have to remove these cells from the bone marrow. We'll have to figure out what to do with the bone marrow so these B cells can be removed. So now they could be living in lymph nodes too, or circulation too. So these kind of treatments can actually lead to a lot of benefit from the patient. Imagine that the patients who are suffering with this, they may actually have these B cells sitting in their bone marrow for rest of their life and producing these bad antibodies, which would just keep chipping away at their tissues and keep causing damage. Which is not sustainable, and that would eventually cause a lot of harm to the patient. So in this case, we'll have to create, just like cancer therapies, we'll have to do something like this to kill these B cells. So they are not cancerous B cells, they're not growing like a cancer, but they're just sitting there somewhere, clustered like a hornet's nest and making bad antibodies. So if I go back here, they're saying maybe, excuse me, maybe we neutralize the antibody secreting cells by anti-CD20 monoclonal antibodies, or CAR T cells may be considered. So this is the, just before the limitation, if you're going to read this study, just before they discuss the limitations, they discuss the possible solutions. I firmly believe that we should take these solutions to our doctors to say, look at this study, here are the possibilities, maybe we can try some of that. So a review of IVIG usage in post-COVID neurological disorder revealed that while virtually all studies show benefit in the patients, only 12 to 76 cases report 16% demonstrated unequivocal diagnosis of autoimmune encephalitis 1. Anyway, so they're giving data for this. So there are multiple possibilities. Now, if I go back up for another few excerpts, What they found was here. What they said was that we find the IgG antibodies here after to evaluate if autoantibodies identified in the long COVID participants or pathogenic after the long COVID participants are pathogenic, we developed a mouse passive transfer model. So what they did was they took antibodies from humans and they had a mouse model in which they'll put this. Mice received 38 milligram per kilogram of IgG, with each mouse receiving IgG from different donor. The mice were co-housed with each cage housing one mouse that received an injection of this and blah. So this is how they check the mouse to see what kind of symptoms the mouse will develop. The thought was that if a patient has musculoskeletal symptoms and you take their IgGs and put them in a mouse, the mouse would also develop musculoskeletal symptoms. If the mice had developed a different kind of a symptom, then they would say this is not the right antibody. So they were matching the mouse symptom to the human symptoms. So when they would move the antibodies for neurological tissue damage to the mouse would also develop neurological symptoms. This is how they verified. After the injection, we evaluated the presence of healthy IgG in the brain and serum, or high IgG something. At 24-hour post-injection, we observed HIgG crossing the blood-brain barrier and concentration of antibody remained relatively constant for 5 days. 5 days after injection, we observed that 5% of the human IgG, so this HIgG is human IgG crossed the blood-brain barrier as measured by ELISA, and at 3-day post-injection, these mice displayed increased thermal pain sensitivity based on the host plate test. So what they're saying is we put the IgGs in the mice. Within 3 days, the IgGs started causing the symptoms, and then they saw the IgG cross into the blood-brain barrier and into the brain. When we compared the hot plate test with the symptoms of the donor, we observed the mice receiving IgG from these diagnosed with chronic pain, inflammatory pain, or neuropathic pain displayed enhanced pain sensitivity at the hot plate test. So again, they're trying to say that mice displayed similar symptoms. That means these were the IgGs that were responsible. That means patients have the IgGs that are causing the problem, which means their B cell have become autoreactive. With 85% of the mice with the pain phenotype having received IgG from participants with long COVID who self-reported new onset pain since their long COVID diagnosis. So these are those patients who didn't have pains before, but now they have pains. The hot plate test was also associated with pain sensations described by the long COVID participants as pins and needles, burning pain, and non-statistically significant trend with electric shock. And I heard that a lot from patients that, hey, it looks like I have electric shock like feeling. The hot plate test phenotype was also associated with weakness and dysautonomia. So patients started becoming weak and their autonomic nervous system started malfunctioning, with 55% of the mice scoring positive for pain receiving IgG from patients who reported weakness and 90% from the patients with dysautonomia. So once again, there was correlation. All the other symptoms evaluated were not significant. The grip strength test. So again, what they're proving here is that they found that patients have IgGs. Why are they proving this? What they're trying to inform us is that it is not that some other thing is working, maybe mast cell is doing something or a macrophage is doing something. They are showing that the patient's B cell is, some B cells have become rogue. They are producing autoantibodies. Those are causing the problem, those antibodies. To evaluate, those antibodies may be inducing pain. So the next thing was they wanted to see how are these antibodies actually causing pain? What is the problem? We performed the passive transfer using this with fluorescent labeling of sodium channels specifically expressed in dorsal root ganglion and peripheral nerve axons that mediated the pain. So what they're saying is, uh, from the spinal cord or to the spinal cord, let's say this is a piece of skin. Here is a free nerve ending. This is a free nerve. There are a bunch of free nerves over here. They would then get together into a sensory nerve for pain. That nerve will have a dorsal root ganglion, which I discussed in detail in previous lectures, especially on Dr. Bean, in the pain management. Then this axon would, or the central axon would reach the spinal cord. It might relay here, it might go to the other side and go up. There are various pathways from here. So they're talking about what they did was they created radiating molecules that can attach to sodium channels in these nerves. Let me make it in blue. So sodium channels are necessary for these nerves to function. So if you have something that is connected to the sodium channel, then you can see that if that nerve is functioning. So now after giving the IgG, they started observing these nerves to see, are they firing? And they saw that these nerves started firing. We observed that the mice injected with the IgG from patients with long COVID had a reduction in the number and volume of intraepidermal nerve fibers when compared with mice receiving IgG from healthy controls. So not only they were firing, their volume started becoming less. That means the nerves started getting destroyed. So they could see less radiation or these radiating molecules because the nerve got damaged. The reduction in the intraepithelial epidermal nerve fiber is a marker for small fiber neuropathy that usually presents with chronic pain, describing as burning pain and or pins and needle sensation. Both symptoms were associated with the hot plate test results. We also evaluated anxiety-like behavior and locomotion, meaning movement, by open field and elevated zero maze, and blood pressure and heart rate evaluated. We did not observe other significant issues. So together, these data show that passive total IgG transfer from people with long COVID induces heightened pain, sensitivity, loss of balance and coordination, muscle weakness in mice, and is associated with symptoms reported by those participants, namely chronic pain, headache, tinnitus, dizziness, and dysautonomia. Now, if you remember this discussion, we have been talking about that German company that does anti-ACE2 antibody and other autoantibody profiles. So here we are with one latest preprint, and this is from Department of Immunobiology, Yale School of Medicine, Center for Infection and Immunology, New Haven, Connecticut. So it is Yale study. And when did it come out? This is 2024, 6/18/2024. So recent. So here we are. This study is right on target for what I have been talking about for the last 2 years. So Sigrid says, just invited more to join in. Thank you very much. Joanne says, much of this is what I experienced in long wax. I'm sorry. So again, the parts of the virus, spike protein, the most toxic part, if you will, and then other parts, they can all cause various kind of pathologies. And if spike protein is used in the wax, then that can happen as well. So of course. That is true. Might be good not to have blood donation from a fine fellow from long COVID. Absolutely, because they would have these possibly they would have these antibodies in their blood, and once they are given to someone, they would also develop symptoms, just like the mice developed those symptoms. You're correct. So this is what I wanted to share, because I think this is really important for long COVID and vaccine injury patients. Now this channel is going to become a target as well because I say vaccine injury here. But really, anyone, I just uh, pasted the links there. So, this is the discussion I wanted to do. Now we can do other chit chat topics. So, Gene, I think that there is a problem with the name, and that is Cool Beans is one word. And I remember I had asked someone in my team to create this channel when I started doing it, and it just ended up with one word. YouTube does allow you to change the name, so I will go and change the name to Cool Space Beans. Alexander says my team equals Luffy. Yeah, so Luffy, poor thing, is nowadays going through some hard time. He had a abscess because he went out and fought with something that altercation, as his doctor puts it. He got bit. That caused an abscess. We had the abscess drained. Surgically, they put him under general anesthesia, drained the abscess, gave him medicines. He stayed okay. Then, as the antibiotics stopped, he developed the abscess again. So, 3 days ago, we had to get it drained once more. So, once again, he's on opioids and gabapentin for anxiety plus antibiotics. And doctor said that if he develops the abscess once more, they'll put a drain in there till he heals. So he's going through some rough time. But he is such a brat that as soon as he comes out of the effect of opioids and gabapentin, he just starts running around everywhere as before. So Sigrid, you are correct. Um, Anyone who has a possibility of autoantibodies in their blood could contribute those antibodies to others. Now, what happens is many times these can be cleared out by plasmapheresis, or these can be removed by the recipient's blood, recipient's immune system, uh, causing maybe no harm, but it can cause harm as well. Alexander says, "Oh no, so sorry for Luffy." Yeah, thank you, Alexander. He's been going through some rough time. So doctor gave me a warning. He said, do cold compresses and make sure that the any new pus is removed, but his wound has healed over. So antibiotics have to do the work, otherwise they'll open the abscess once more and put a drain in there. So that's what's happening. And I do not know if you believe in evil eye. There was a guest who looked at that cat and they said, "What a beautiful cat you have. I've never seen a cat like this. He's so uh, communicating and he looks into your eyes and he is so loud." And then the next day, Luffy had the abscess on his back. Okay, so what other topic should we discuss? Cynthia says cold compresses on a cat. Yeah, so I've been doing that, but hasn't last time it as soon as his antibiotics stopped, he started developing the abscess again. This time they've given the antibiotics for 2 weeks. So let's see what happens. So Jean has a good question. What implications do these autoantibodies have for future infections or vaccines that might reactivate or modify immune response to these patients? So every time, so there's a concept in immunology that is called affinity maturation. Affinity maturation is that imagine I am a B cell and this is my antibody binding site, variable region. And imagine its shape is like this. So I'm going to grab hold of something that let's take my anti-allergy. So let's say the shape of my binding site is such that this can fit in there. That means I can make antibodies that can attack anything that looks like this. However, if this antigen continues to attack me or continues to trigger me, then I would keep becoming tighter and tighter and more precise and more precise and more active and more reactive, more precisely reactive. That is called affinity maturation. So, with each exposure, we might make new B cells which may have slightly different binding sites. Plus, we might mature the older B cells to do even better in action, which continues to cause harm. If it is causing harm, then those antibodies would just keep doing it. This is a very good question. Alexander says, is there something to do for this remaining cough that so many people have right now seems to come from the last few COVID variants? Correct. So I developed that as well, and it was just such a long one. And now I have barely come out of it. Thankfully, I can now speak for some time without coughing. Um, the things that I did was, this is why I have this here: anti-allergy, Flonase. So anti-allergy to reduce the secretions, Flonase, because this cough, one reason for the cough is the post-nasal drip. And it is so interesting that when you tell a patient that you're coughing because there is drip in your from your nasal posterior part of the nose into your throat, and that irritates you and you cough, they don't believe it. They say, I don't feel any nasal drip. So you don't have to feel the nasal drip. It can drip. And especially when you sleep at night, it would drip a lot and it would get, stuck to the throat. And then when you wake up in the morning, you have a lot more cough as well. So I use this regularly morning and evening. This is Flonase. Uh, Flonase. And then I take this. Plus, I also take the third common reason is if the GIT is producing acids and there is GIT stomach is producing acids, there is acid reflux that also causes cough. That if the acid content comes all the way to the throat, then it can irritate the throat and person can cough. So I take a famotidine tablet as well morning and evening, and that has cleared majority of my cough. But when I was sick a few weeks ago, when I traveled to New Jersey and I came back and I was sick, I believe I caught COVID. I was not using Cofix RX. Then I really was coughing a lot. Then when I went to Los Angeles, I used Cofix RX more religiously and I didn't develop any problems. So this is one way. Aspirin has been very good for this cough as well because it reduces inflammation. Parth says, what about your immunology book? So my immunology book took a slight turn towards inflammation system book. And that book, I have done all the content. Now it is being written, meaning being written that you write it and then you revise it and revise it. My publisher says we'll revise it 8 times. So we are working on that now. Thank you for asking, Parth, and thank you for being here. Calendula cream for Luffy. We'll see. So his surface skin is fine. It's the abscess inside. Sita is here as well. Hey, Sita, how are you? There are so many cool beans here. David says, can long COVID cause migraines? Yes. So actually the same paper would actually show you that headaches can occur. Now, migraines are headaches that get triggered with some kind of a trigger and mostly a specific part of the brain. But yes. So Sigrid says warm pack. So yes, doctor had asked me to do warm compresses and I have been doing that. So I'll do more with Epsom salt as well. Alexander says, thank you. You're very welcome. Jean says, how about your wife's remedy of ajwain tea for persistent cough? That works very well as well. NSE works very well as well. Actually, the way NSE works is that it breaks the sulfur bonds or disulfide bonds. And one reason for the cough is that the mucus that is here, that gets more organized, meaning it becomes dehydrated, the water comes out of it, and the sulfur bonds, they start joining with each other and make double disulfide bonds, it becomes very difficult to break the disulfide bond. So when you feel sputum that is kind of hardened, that is disulfide bonds in it. NSE breaks those bonds. Glutathione also breaks those bonds. So glutathione or NSE is preferable. NSE used to be used for antitussive, meaning it would break those bonds and clear out the sputum or the mucus and cause the airways to clear up. So yes, very good gene NSE. And her Adjuvanti is amazing as well. Yes. So Paul says, when can we start buying your book? So my hope is within few months now. Previously, I was more at delayed because I had the writing, but I didn't have the diagrams, etc. This time, the inflammatory pathways lectures. There are diagrams, there are writings, there is video. So three parts are already present. I am now working on the labs part of it, but there's a lot of content already produced that is being put together. So my hope is a few months. Margaret says, many prayers for Luffy. Thank you very much. And guess what? We are 28 today. New channel. So this is very good. I had really bad acid reflux 6 months ago. Pepsid made it better temporarily, then much worse. Then I got better results with Phillips milk of magnesia. Milk of magnesia is very useful as well. So this is a very good question. Jean says, what are the potential side effects of long-term IVIG use in long COVID, particularly for those with autoimmune tendencies? So the IVIG, as I had discussed once before, it is really a pool of antibodies from a community. So imagine my town. People over here are giving and donating blood. You take antibodies, immunoglobulins from that blood and filter them out, and then you wash them and you kind of clean them and you bottle them. So now that is an average of all kind of diseases that are in this community and the immunoglobulins against them. So when you give it to a patient, the hope is that those IGs would attack any other pathogen or RNAs or spikes or other autoantibodies running around and clear them out. So every time you take IVIG, it is possible that there is an inflammatory reaction that would happen when the body's immune system would attack the incoming antibodies, and the incoming antibodies would attack something that is already present. So that is a more short-term feeling of the inflammation. Other than that, the only thing that I can think of is that we developing new autoantibodies against those antibodies that are coming in, but that is rare. People can actually use this for a longer period of time. The important thing to note is that all of these solutions, IVIG, plasmapheresis, antibody neutralization, they are all responses, they are all management of the outcome of bad B cells. The right and correct answer or management will be to remove those B cells. And so we have to kill those B cells. That is the right answer. And so for that, either CD20 antibodies or anti-CD20 antibodies or CAR T cells that kill those specific B cells. I think that technology is there now, but CAR T cell therapy is very expensive. Anywhere from $500,000 to $1 million is for CAR T cell therapy. But I think that when a patient who is long COVID patient and the other pathology included as well, their life can be ruined by this continuous pathology. So insurance should cover it. Paul says, let's have a few more likes for Dr. Bean today. Thank you very much, Paul. So I think this is a success today. We have 29 people now. So what do you think? Should we uh, break, and we should do this every Friday on this channel. However many people, if there is interest, will keep doing it. Leroy says you're competing with the Dodgers versus Yankee World Series game night. Bold business move. I'm assuming you don't have a dog in the fight. Good luck with the new show. Thank you very much. No, I don't have a dog in the fight. So Sigrid says yes. So cool. So I will let you watch the game. And Sita says every Friday, yes. And let's try to do it every Friday, and we'll go from there. Mike says sounds good. Cool. So with this, Paul says keep doing it as far as I say. Excellent. And Paul, this also gets the need for me to speak at length for some topic. That need gets out of my system as well with speaking for 1 hour or more. So it's a therapy for me as well. Leroy says subscribe, like, and comment for the algorithm. Thank you very much. And with this, please have a nice weekend. We'll have a morning walk on Zoom tomorrow at 7 a.m. Pacific time, and enjoy your game night. And I'll see you all next week. Paz says, love you, sir. You are doing great work. Thank you. Jean says, great show. Thanks. You're very welcome. Sigrid, it's a date. It's a date. Done. See you next week. Jean says, thanks, doctor. You're very welcome. Sita says, thanks. You're very welcome. So bye for now. And next week, we'll talk again.